it. Chapter 3, we're talking about trigonometry, so we're going to review some familiar topics. You guys are going to not so much learn, but again, more so refresh your knowledge of right triangle trig to find missing angles and sides. I'm going to try to cover as much as I can for this short day. Remember that trigonometry is the study of the relationship between angles and side lengths of a triangle. A lot of careers use trigonometry, engineering, architecture, building physics, astronomy, navigation, and so many more. Okay, it's definitely one of those concepts that you do anything that deals with any type of measurement or any type of angles, you're going to be using trigonometry at some point. Maybe not Sohcahtoa, maybe not, but it's going to be probably something that's more advanced that uses Sohcahtoa as a base. Don't forget that you have these special relationships between the sides of a right triangle in relationship to some acute angle. Okay. And that's where Sohcahtoa comes from, okay? Remember Sohcahtoa were the different types of relationships between finding side lengths and angle measures in a right triangle only. Sohcahtoa is used only for right triangles. What did the S stand for? Sine. The sine of your angle was the opposite over the hypotenuse. Very good. C stood for? Cosine. So cosine of your angle was adjacent over hypotenuse. And the last one, T? Tangent of your angle was opposite over adjacent. It hasn't changed from geometry. That has not changed either for IB. Okay? So it's still all the same. Do you guys remember this? Yeah. Remember, theta was always your acute angle. So it's never based off of the 90-degree angle. Always one of your acute angles. Okay? How many degrees are in a triangle? 180. Okay? So if you already have 90 that's taken care of by the right angle, then that means that these two angles, theta, let's just say theta prime, have to add up to equal 90 degrees. Hence why they would both be acute. Okay? So, let's find the ratios of this particular triangle theta here. Ratios. Ratio is another word for fraction. So I'm looking for the fraction that represents the sine of theta. Sine is what over what? What's my opposite side here based off of theta? 5. What's my hypotenuse? 8. Good stuff. So my ratio is going to be 5 over 8. If that ratio can reduce, then you want to make sure that you do reduce. Always reduce. Always simplify. Yes? Okay. Cosine is what over what? Well, we don't know the adjacent. What other old school concept is used when it comes to right triangles? Pythagorean theorem, sometimes referred to as Pythagoras' theorem. Okay. And what is Pythagorean theorem? A squared plus C squared equals C squared. Where C represents your what? Hypotenuse, and A and B represent your adjacent opposite sides. So basically your legs, okay? This is your hypotenuse. These two sides are known as legs of your right triangle. They always form the 90-degree angle. So we use Pythagorean theorem to find the missing side length. We are going to do this without a calculator so that we won't have any decimal approximations for simplified radicals. What's 5 squared? 8 squared? 64. So I need to subtract. A squared is equal to 39, and we need to square root. Now, normally when you square root an equation, it's always plus or minus, but we're talking about the length of a side, so it has to be positive. Does the square root of 39 simplify any? No. So our adjacent side is the square root of 39. So then the cosine would be the square root of 39 over 8. Tangent would be what? Can I have this? No. You cannot have a radical in the denominator. Well, sometimes you can, but not in these particular cases. How do I simplify this? And Alex, what's that called? Rationalizing the denominator. So I'll have 5 square root of 39 all over 39. Y'all remember this? Yep. Easy peasy lemon squeezy? Good stuff. Okay. Keeping it going. Fine. Now I need my calculator here. So go ahead and pull out your calculator. I'm going to find the unknown length in each one of these triangles. I'll do the first one with you to refresh your memory in case you've forgotten. I want you guys to do the other two on your own. Remember, you always identify the acute angle you're either using or is given to you or that you're trying to solve, and you label your sides based off of that angle. X would be my what side in example A? It would be my adjacent. Remember, adjacent is another word for next to. It's the side that's next to the acute angle. That's not the hypotenuse. What's the 11?
The hypotenuse.
It is the hypotenuse. Which trig function has adjacent and hypotenuse? Cosine. So I'm going to set up the equation. Cosine of 47. Remember, angles are always attached to your trig function, so you cannot separate them. They're always together. Equals my adjacent side over my hypotenuse. To solve for x, I need to what? Cosine 47 times 11 is going to equal the value of x. And I want to make sure that when I do this in my calculator, especially these fancy ones, I need to be in degree mode. So when I click my mode button, which is located right beside my second button, I can see that on my fourth line, I'm in radian. So I go over to degree, I click enter, and now I can actually figure out this problem. Yes, you will be alternating between the two modes. So a good rule of thumb is that if the problem is given to you in degrees, you want to be in degree mode. Okay? So now that becomes 11 cosine 47. And my answer, did you guys get this?
Yep.
3 significant figures? 7.50 meters. Questions?
Nope.
Do the other two. What trig function am I going to use for B? Tangent? Yes?
Yes.
What's my opposite side? Adjacent? Good stuff. So here I'm going to do the same thing. I'm going to multiply 3 times the tangent of 69 to equal x. And what's my answer? 7.82. Good stuff. If you object, please make sure you speak up. Okay? C. What trig function? Sine. So it's going to be sine of 56 equals my opposite over my hypotenuse. Very good. Now this one's different from the pink and the blue because the variable is in the denominator. So when that happens, you're actually going to end up doing what to find x? So you're going to divide by the sine of 56. So 4 divided by the sine of 56 is going to give you your value for x, and x is going to equal 4.82. Y'all remember this?
Yep.
Good stuff. All right. Don't forget, you also use Sohcahtoa to find the value of an angle. Anytime you're looking for an angle, you must do the what?
The inverse.
The inverse. You must do the inverse when you are looking for an angle. You still set it up the same way, but this time you'll do the inverse. So again, let's identify. 3 is my what side? Adjacent. And 5 is my what trig function uses adjacent and hypotenuse? So it's going to be cosine of theta equals 3 over 5. So I'm going to do the inverse of cosine to find the value of my angle. Again, I am in degree mode, so I don't have to worry about switching, because once you switch to degree mode, you're there unless you reset your calculator or you change out the batteries. Okay? So that's the second button, then the cosine button. 3 divided by 5. I close it off, and I have my answer. Did you guys get this? What's theta? 53.1? Very good. Questions? Do the other two. Over here for B, what trig function did you use? Sine. So then that means that what was my opposite? And my hypotenuse? So then you did the inverse of sine. 5 over 7. What was your answer? All I heard was 0.6. 45.6. Good stuff. And then what about the last one? The trig function? Tangent. What was my opposite? Adjacent. So then I do the tangent inverse, and I get an answer of 2.6?
Or 2.4.
Wow, I heard the wrong thing altogether. 13? 13.7. Okay. I'm hearing all types of numbers. 13.7. Have we forgotten? Okay, let's keep it moving. Now, one thing that was mentioned back in your geometry classes, because I remember this, I used to teach geometry, that is something that is forgotten, I want you not to forget, is that you can create right triangles in certain geometric figures, okay? When you have an isosceles right triangle, what does isosceles mean? Two sides are congruent to each other, so like these two sides make this triangle isosceles. When you take the vertex angle and you drop down a perpendicular, it does create two right triangles where those two, that base side is cut into two equal pieces, okay? Equilateral means what? All the sides are equal. Again, if you drop down a perpendicular, you create two right triangles, and in actuality, both of those sides are equal as well. Okay? If you look over here to your rectangle and your square, remember, rectangles and squares have 90-degree angles in them, so when you draw a diagonal, you are creating right triangles. Same thing with the square. More specifically, what do you know about the sides of a square? They are all equal, okay? So don't forget about that, because they may tell you what the diagonal is of a square, and then ask you to find those sides, and you've got to remember they're both equal, so then you know the Pythagorean Theorem or whatever, what have you. Down here, for a square and a rhombus, okay? The diagonals in a square, they do intersect to form 90-degree angles and congruent pieces. Same thing with your rhombus. The diagonals of a rhombus intersect to form 90-degree angles. However, because one diagonal is longer than the other, these two are equal to each other, and then these two are equal to each other. Okay? In a kite, the diagonals of a kite intersect to form 90-degree angles, but not both diagonals are equal to each other, just the two that are on the shorter side. Okay? Looking at a circle, we're going to look at this one down here. If there is a line that's drawn tangent to a circle, first off, tangent means it intersects at one particular point, the point of contact. The radius and the tangent line, they do form a 90-degree angle, so you can draw a hypotenuse between the end of your tangent line and the center of your circle. Did everybody see it? And please don't forget, as well, when you look at this, if the radius is 6, then you know this distance also is 6. All radii in a circle are equal, students. Students tend to forget that. Looking here at this circle, if you have two radii that you connect with a cord, from the center to that cord, it does form a 90-degree angle. Of course, all radii are equal to each other, and that causes the cord to be bisected, split into two equal pieces. Last but not least, one of the most forgotten ones is that if you have a semicircle, in other words, this would be the diameter of your circle, and there is an angle, a inscribed angle, whose vertex is on the circle, it does create a 90-degree angle. It only works with the diameter, no other point. Okay? So no matter where that point is, still creates a 90-degree angle, as long as the ends go to the diameter. All right. So let's look at these two examples here that deal with the geometric shapes, and then we'll move forward from there. The diagonal and the longer side of a rectangle make an angle of 43.2 degrees. If the longer side is 12.6, find the length of the shorter side. What do I need in this picture? What main shape do I need? I need a rectangle. So I have my rectangle. I need to draw in a diagonal. And it says the diagonal and the longer side of the rectangle make a 43.2 degree angle. Where am I going to put 43.2? Would it go here?
No, that's right.
That's the right angle. Okay. Would it go here? It's the shorter side of the diagonal, so that means it has to go here. Yes? Okay. Now it says that the longer side is 12.6 centimeters, so then that means that this will be 12.6. And it's asking me to find the length of the shorter side, which is this. What trig function am I going to use? Tangent. Am I using the inverse? No, because I'm not looking for an angle. What over what? X over 12.6. So again, to find x, I just have to if you notice, I will always write out that line that should be what you type into your calculator. So then that way, if you ever don't end up with the same value as everyone else, you have this to reference.
Wait, what do you mean by line?
This line right here of x equals with the actual multiplication of the two. Like I'll write that every time we do any type of trig problem. So in that way you'll know, like if your numbers don't match up with the numbers that somebody else is getting, go back to this and make sure you're typing it in exactly how you see it. What's my side? 11.8? 11.8 centimeters. Don't forget those units. Don't want to lose that 1 unit penalty, especially when we're talking about these word problems, okay? Or anything that has units, to be honest. The smaller angle of a rhombus. All the sides of a rhombus are what? They are equal, okay? You get a good geometry review today, okay? All the sides of a rhombus are equal. And it says the smaller angle of a rhombus measures 21.8. This would be the smaller angle, 21.8 degrees. Then it says the shorter diagonal has a length of 13.8. So I need to draw my diagonals. Yeah. Well, good luck. I appreciate it. Because if I wasn't, I'd be like, no. Okay. Now, since the shorter diagonal has a length of 13.8 centimeters, does that mean that from here to here is 13.8 or the full shorter one? The full shorter one is 13.8. Okay? So, with that being said, you're going to have to probably do a little bit of geometry and knowledge of rhombi, so in that way you can find the length of the sides of the rhombus. Can you guys go ahead and work this one out? Try to work it out? Okay. So be careful with this particular problem. Again, you have to know your knowledge of rhombi to be able to answer this problem. Remember, the diagonals of a rhombus intersect to form 90-degree angles, and they also bisect each other. So that 13.8 actually turns into what? 6.9 on both sides. Okay? Now the diagonals also, I didn't mention this, but I wonder if anybody picked up on it, does what to this 21.8 angle?
It bisects the angle.
It bisects the angle as well. So what is this angle here?
It becomes 10.9. Yeah.
10.9? 10.9 degrees. So basically you have a right triangle. Let me redraw it. Where this side is 6.9 and this angle is 10.9, and I'm trying to find the side length, which would be this value right here. What trig function am I going to use? Sine. Because my opposite side is, and my hypotenuse is x. Here, am I going to multiply? I'm going to divide. So 6.9 divided by the sine of 10.9 is what? 36.5 centimeters. If it asks for the perimeter, you basically multiply that by 4 to get your perimeter of your rhombus. All right. I want you guys to try these. Try these. You're looking for the radius of the circle for A, and then you're looking for the unknown value, which is theta, or alpha, I'm sorry, in the other one. It's not labeled. So in this particular problem, we are looking for the radius. Okay, we know the radius is how much of the diameter? It's going to be half, so we're probably going to just have to find the diameter and then divide by 2 once we figure that part out. What is this angle right here? It is 90 degrees because the ends of its angle are on the diameter and its vertex is on the circle. So this is a right triangle inside of this circle. Which trig ratio I'm going to use to solve for x? Cosine. So it's going to be cosine of 34 equals adjacent 4.3 over hypotenuse x. Multiply or divide? Divide. 4.3 by the cosine of 34, and whatever that answer is, I'm going to have to divide that answer by 2. Did you guys do that? What'd you get? 2.59 centimeters. Good stuff. Okay, let's move on to the next one. Okay, it says find the value of alpha, and we're given this. These two lines are called what? Tangents. They are called tangents. There's actually a formula that's used to find that angle if we were given the measure of the arcs, but we're not given the measure of the arcs here, so we got to do a little bit of math. The radius is 6, which means that if I were to draw the radius here, this 2 would be 6, and the radius in the tangent line would form a 90-degree angle. Okay? Same thing over here. This is 6. It will form a 90-degree angle. I can draw the hypotenuse. Okay? Not necessarily a kite, but I mean pretty much we can use either one of these triangles to find the measure of alpha. Two tangents, if they intersect at a point on the outside of the circle, they're actually the same. So this 2 is 10 on that side. Okay? But I'm basically looking for this angle right here. Once I find it, I just have to multiply by 2 to find alpha. So it'll be tangent. 6 over 10. Here, I'm going to do what to find theta? I got to do the inverse of tangent. 6 over 10. Is that what you got? So we're going to figure that out, and then we're going to multiply it by 2. So 2 theta, in other words, alpha, which is what I'm looking for, is what? 61.9 degrees. Questions on using the geometric shapes to use trig?
On the first one,
yes.
Can you go from like the center point and like draw a line out to the edge of the circle and do it that way? Yeah, like that.
You could. The only thing is that segment is not going to bisect that 90-degree angle to make it a 45, and so you wouldn't be able to do that.
But can you make the center like a 90?
Here, make it 90? Yeah. No, you wouldn't be able to do that. All right, let's do the last little bit. We're going to go angles of elevation and depression. Okay, this will play a part as well in non-right triangles, but we're only going to stick to right triangles for the moment. And you're due now on Monday. Tuesday is going to be it's going to be a good one that deals with right triangles. So, angles of depression. The main thing that students, it never fails how many times I say it, how many times I overemphasize it. There's always going to be one, and there will be one here, that will try to incorrectly place your angle of depression. Please, when you draw your angles of depression, because it's always hard for depression is elevation, it must come from some horizontal line looking down. Look at this man at the top of the building, right? When he spots this car, his angle of depression comes from a horizontal line of him looking out at the world and then going to look down. That right there is your angle of depression of 15 degrees or whatever degree the problem is saying, okay? It's never between the building he's standing on and then his line of sight. It always comes from a horizontal line. This horizontal line is so flippin' important. Please make sure you draw it out before you commit to solving whatever the question is asking you to solve. Horizontal line going down is depression. Horizontal line going up is elevation. And must we not forget from geometry, because today is a good day of review for your SAT and your ACT, is that these two angles here, here, and here are what? Because they're what kind of angles?
Interior.
It wasn't opposite.
No,
It was. What's another word for opposite?
Alternate.
They were alternate interior angles. Alternate interior angles are always congruent. That's why angles of elevation and depression are equal to each other. So the angle of elevation from the car to the person is the same as the angle of depression from the person to the car. Okay? Here, I just attached the picture so then that way you guys wouldn't have any issue. But it says the angle of depression from the top of a 20-meter high vertical cliff to a boat B is 8 degrees. Again, here's the top of the cliff. Looking out, there's your horizontal. Then looking down at B is your angle of depression. How far is the boat away from the base of the cliff? What part in this picture are you looking for? That bottom line, the C, right? You're looking for this. Now, in this particular triangle, because the vertical cliff does make a 90-degree angle with the C.
Oh, you also have, because of alternate interior angles, you have your angle of elevation down there.
Yes, and because of alternate interior angles, you have your angle of elevation down there at B. So that is 8 degrees. What trig ratio am I going to use? Tangent is going to equal what over what? 20 over x. Multiply or divide here? And what's 20 divided by the tangent of 8? 142? Yes? Let's look at this one. A storm water drain has the shape illustrated. Determine the angle beta where the left-hand side meets the bottom of the drain. How do I find beta? Let's brainstorm first, individually, and then we'll come back together with ideas. Suggestions on how to find beta.
You can
Make a rhombus.
You can make a right triangle by dropping down from the 5 meter straight down and attaching to the 2 meter. Oh, that's not what I was thinking. Okay.
I thought that was what you're talking about.
Which one?
Outside, the end of the 5 meter.
The end of the 5 meter. So you're talking about outside the
Yes, outside of the.
Okay.
Because that would still be 3.
This will still be 3, yes.
And then attaching to the 2 would be 3 because your 2 bases would have base 1 minus base 2 would equal, because it's forming a rectangle.
He's right, it'd be 5 on bottom too.
Or no, because there's a distance between.
Yeah, the whole thing is 5.
No, because there's a distance there.
When those is 2 meters the little bottom part.
Yeah.
So maybe 1.5.
Nah, but see, we don't know for sure if that's
See,
equal.
but if you do what Zach was saying, you can, the bottom line would be 180 degrees. So on the other triangle, you can figure out that one by making the other side 80 degrees.
Okay. So you're talking about in this triangle here, right?
Yeah.
Okay. So in this skinny triangle here, if I make this 80 degrees, and this is 3, what would I find?
Solve for your adjacent.
Solve for my adjacent. So I'm going to use A for adjacent. So that's going to be tangent 80 equals 3 over A. What is that? 0.53. It stops right there.
Well,
No.
Well,
0.5 of the 2.
0.5.
2, 9.
8, 9.
Okay, since I have to use this to do more, you want to use the long decimal, right? So if this is A, that's this little bit right here. Now you said that whole bottom side that I drew to create this rectangle equals 5. So then that means that on this side, this little part is how much?
You can subtract it from 5 though.
So I can add that 5.289 number to 2, subtract it from 5. 2.47 and some change, right?
Yeah.
Because I have to use that now to find what?
You're adjacent to 2 point.
That angle right there. Very good. Okay, what trig ratio am I using here?
Tangent.
And this time since I'm looking for an angle, I use my inverse. I'm not using the rounded number. I'm using that full decimal. So what's the tangent inverse of 3 divided by that answer that's still on your calculator?
50.52 and a lot more change.
So then to find beta, my final answer, what do I do?
180 minus that.
180 minus that number, and our answer is what?
129 rounded.
129. Hold up. 129. 129. Yes. Very, very involved. I wouldn't have taken it that route, but you definitely get your answer. You definitely get your answer this particular way.
What have you done?
But this is how we can use and apply right triangle trig a little bit more advanced. I felt like I chose these problems, so I felt like it was a little bit more than just, rudimentary, like what you saw at the very beginning. Okay? Getting you a little bit more involved, but still applying the same old school concepts. Okay?